Chapter 3 of the Electrician Program, Tools for the Modern Electrician. The objectives include information in this chapter that will enable you to select essential tools for residential wiring, know the specialty tools available for infrequent applications, and to discuss basic principles of tool use and care. Some of the technical terms discussed in this chapter are blanket heater, box heater, cable ripper, circuit tester, conduit bender, continuity tester, diagonal cutter, digital voltage tester, the electric drill, the electrical voltage tester, electrician's hammer, electrician's knife, fish tape, flux, folding rule, grooved joint pliers, hacksaw, hammer drill, the hickey, the hydraulic bender, level, lineman's hammer, lineman's pliers, locking pliers, long tape rule, multimeter, needle nose pliers, pipe cutter, pliers, the Reamer, receptacle tester, reciprocating saw, and the rotary hammer drill. Others include the sharpening stone, the solder gun, soldering paste or flux, the solenoid voltage tester, steel tape, the torpedo level, the whetstone, and the wire stripper. An electrician must have proper tools for the job. Tools must be kept in good repair. If tools are not available or are in poor condition, time is wasted and good work is impossible. Invest in good quality tools and take time to inspect and care for them, and you will be able to rely on these tools for many years. Safety note: homemade insulated tools. Insulated tools have been tested to prevent conductivity at the voltage for which the tool is rated. Do not think that you can insulate a tool by dipping its handles in a polymer or wrapping them with tape. These methods create a weak and inconsistent thickness of insulation. If you must work on energized equipment, the cost of insulated tools is a small price to pay to prevent injury or even death. Measuring tools. One of the most important tasks for an electrician is measuring. Whether you need to measure distances, electrical properties, or a wire diameter, proper measuring techniques and tools will make the installation quicker, more accurate, and safer. All measuring tools must be handled with care to ensure accuracy is maintained. Tools for measuring distances. The most frequently used measuring tool is the power return steel tape rule, also known as the steel tape. The steel tape is a coiled strip of thin steel that is marked with fractions of an inch or other measurement scales, such as metric. The bent metal hook on the end of the tape butts up against surfaces for inside measurements, or hooks up over the objects for outside measurements. The hook is designed to slide a distance equal to its thickness. This ensures an accurate measurement, whether placing the hook up against an object, an inside measurement, or hooking it over the end of an object for an outside measurement. Always slow the end of the tape just prior to entering the case to prevent the hook from breaking off the tape. The typical steel tape lengths are 20 to 35 feet, with 25 being the most common. The width of the tape should be at least 1 inch so that the tape remains stiff enough for a single person to make most measurements. Be careful when using steel tape near powered equipment and conductors. If the steel tape contacts an energized conductor or component, you could receive a shock. A safer measuring tool near live equipment is a folding rule. Distances that are beyond the steel tape's reach could be measured with a 50, 100, or 150 foot long tape rule. These rules are made of steel or woven fiberglass and are retrieved with a manual crank. Folding rules are distance measuring tools that are available in wood or fiberglass, which makes them safer near live equipment. Typical folding rules are 8 foot, 6 foot, and 10 foot long with hinges for folding at 6 inches intervals. A well-built folding rule will last for many years, requiring only a drop of oil at the hinges once a year. Both the steel tape and the folding rule can be found with U.S. customary, metric, or both scales. Tools for testing and measuring electrical properties. One of the most important tools for preventing electrical shock is the electrical voltage tester. This simple electronic device will indicate if a voltage is present on a circuit. Some testers will also show the amount of voltage, usually 120 or 240 volts. A digital voltage tester is a tool that uses indicator lights or a digital readout to indicate the amount of voltage present. This tester draws very little current from the circuit. A solenoid voltage tester, or WIGI, uses a higher amount of current to activate the tester's solenoid, which indicates the presence of a voltage. This meter is also called the WIGI, since the Wigington company developed early solenoid meters over 100 years ago. See Figure 3-2. An inexpensive tool called a circuit tester is simply a neon light bulb attached to 2 conductive leads. When the lead contacts are powered, contacts a powered terminal or wire, while the other lead touches a grounded conductor. The neon bulb will light. The version of this tool is called a receptacle tester, which plugs into a receptacle and will test correct wiring, open ground, reverse polarity, open hot, open neutral, and hot on neutral in AC circuits. Some units will even test GFCI receptacles for proper operation. See Figure 3-3. As a safety note, test the test light. Use the test light on a circuit known to be live to make sure the test light itself works. Then use it on the circuit that you are about to work on. Here are a few descriptions and definitions. You can read these definitions with the green characters, green letters, as you go through the chapter. These definitions are part of the chapter, so I won't be reading those separately. To measure electrical properties such as electromotive force, current, and resistance, you will need a multimeter. See Figure 3-4. A multimeter is also known as a VOM, or a volt ohm meter, or a volt ohm milliamp meter, which comes in a variety of configurations and prices. Some models only test for the basics: voltage, resistance, and current. Others include settings to test for capacitance, temperature, and frequency. A digital multimeter will display the measurement of a digital readout on a digital readout. An analog multimeter is recognizable by its multi-scaled display with a needle that rotates from left to right. Before using a multimeter, you must know the type of currents, AC or DC, the appropriate voltage, and the approximate current. A multimeter is quickly destroyed if connected to a circuit that has more amperage or voltage than the capacity of the meter. Safety note: know what you're measuring. Always know how much voltage is present in the circuit. Using a handheld meter is a high voltage circuit may damage the meter and possibly cause injury. Finally, there may be times when you do not have a meter handy, but need to test a wire or device for continuity. The continuity tester is an inexpensive tool that lights up when a circuit is continuous. These testers are small enough to carry in your tool pouch or shirt pocket, just the one in figure 3-5. Tools for measuring level. A level has clear tubes that contain fluid and air bubbles, or one air bubble. When the bubble is centered between the marks on the tube, the tool is level. Boxes. A torpedo level is a level that is small enough to be carried in a pouch. Some models are magnetic, which is a handy feature when mounting on steel boxes or steel piping. A groove that runs along the length of the level is used when leveling conduit or pipe. All levels have bubbles for horizontal and vertical alignment. Some can line objects at a 45-degree angle. See figure 3-6. Professional tip levels. Your wiring job will not appear professional if the switches and outlet receptacles are not plumb or straight up and down vertically. These are devices that the homeowners will see every day. When installing boxes, always use a level to ensure the box is plumb instead of relying on your sight alone. Wire tools. Having the proper tools to cut, strip, grip, and pull electrical wiring is critical to being an efficient electrician. There are many different types of wire and cabling that you will need to work with. Having the right tools and skills to use them will make the job easier. Cutting. Most wire in a residential installation will be small enough to cut with a pair of side cutting lineman's pliers. A tool that is designed to only cut wire, such as a diagonal cutter, is handy when you have to reach into a crowded space to cut a wire. However, a dual-purpose tool, such as a pair of lineman's pliers, will be used for most of the wire holding, shaping, and cutting. See figure 3-7. The larger cable is cut with long-handled cable cutters, ratcheting cable cutters, or hydraulic cutting tools. If there are only a few large cables to cut, a hacksaw is slower, but certainly adequate for the job. Never use more than reasonable hand pressure, handle extenders, or a hammer to squeeze the handles of a cable cutter closed. Get a larger cutter or hacksaw instead. Safety note, insulated tools. If you must work on powered circuits, always use insulated tools. The insulated tools should be rated for the voltage of the circuit. Stripping. Stripping insulation off of the end of a wire without damaging the conductor is a skill that takes practice and the proper tool. If the tool cuts deep, the conductor could be nicked and be unusable. If the tool does not cut deep enough, the insulation will be very difficult to remove, and a simple wire stripper has circular notches that are sized for standard wire sizes, such as figure 3-8. Place the wire into the correct notch. Squeeze the handles and slide the insulation off of the conductor. Some automatic wire strippers will grip the wire and strip the insulation in one squeeze of the handles. Wire strippers are specifically designed for solid and stranded wire. Be sure to use the tool that is made for the wire you are stripping. See Chapter 5. Conductors. For more information on solid and stranded wire, see again Chapter 5. A multi-purpose tool has features that will cut and strip wire, crimp terminals, and cut small bolts without damaging the threads. The cable ripper, such as the one in figure 3-10, is a tool that cuts the outer jacket lengthwise on multi-conductor cables. See again figure 3-10. To use the cable ripper, place the tool on the cable so that the blade makes contact with the cable's jacket. Squeeze the ripper together until the blade pierces the jacket. Now slide the ripper to the end of the cable to rip the jacket. Finally, a knife is used to cut the jacket completely off the cable. An electrician's knife has many uses. It can be also used to strip insulation and cut electrical tape. A good quality electrician's knife will remain sharp for many uses, but eventually all knives will need to be sharpened. A small sharpening stone or whetstone is used to sharpen the knife. To sharpen a knife, push it away from your body at a consistent angle on the sharpening stone. Make sure to sharpen each side of the blade at equal numbers of times. Gripping. Pliers are used to shape the end of a wire so it can be attached to a switch or a receptacle properly. Needle nose pliers provide the perfect form to wrap a wire around for this purpose. You have learned about the cutting feature of lineman's pliers. The gripping feature is just as important. Electrical boxes have partially punched features called knockouts that are easily removed with the gripping power and leverage of pliers. There are many different styles of pliers offering unique advantages. These styles include locking pliers for a strong grip and grooved joint pliers for a larger range of sizes. See figure 3-13. As you can see, pliers are quite versatile. These tools can grip, clamp, tighten, turn, pull, and cut objects. Certain rules should be followed to prolong their usefulness and make them safe. Never use pliers to strike another object. Do not use pliers for cutting unless the pliers are designed to do so. Keep pliers properly oiled. For electrical work, use pliers that have insulated handles. This will help protect against electrical shock. Pulling. Pull wire through conduit with a tool called fish tape. A fish tape is a spool of steel or fiberglass that it is stiff enough to be pushed into conduit, yet flexible enough to follow the conduit bends. After the tape is pushed into the conduit and the tape's end emerges, the wire or wires are attached to the end. The fish tape is then retrieved, pulling the wires into the conduit. Conduit. Conduit is a flexible or rigid protective tubing used to contain wires. There are specific methods and tools that make cutting and bending conduit effortless and precise. Some tools may be used on all conduit, but most are designed for conduit that is made for a particular material. Learn how to use each of these tools and practice cutting and bending conduit with them. These are important skills to have as an electrician. Cutting. Steel conduit is typically cut with either a powered or manual saw. A good power tool for cutting conduit is a reciprocating saw. This saw comes with a corded or battery powered model and can be outfitted with different blade types and lengths depending on the material being cut. For manual sawing, a hacksaw is a popular metal cutting tool. The blades for a hacksaw are selected based on the number of teeth per inch. A blade with 18 to 24 teeth per inch is a good choice for cutting most types of conduit. To ensure straight cuts, the conduit should be held in a pipe vise. This vise is also required when cutting threads onto a rigid conduit. See Figure 3-17. A tool called a pipe cutter is sometimes used to cut various types of conduit. This tool works by forcing a hardened cutting wheel onto the conduit as the tool is rotated around it. The wheel is pushed deeper into the conduit by turning the handle after every rotation. The drawback to this tool is that it creates a larger burr on the inside edge of the conduit. All cutting tools will create some type of burr, but a pipe cutter creates the largest. The burr inside of the edge of the conduit can damage the wiring, so after the conduit is cut, this burr must be removed. This is done with a reamer, a tool that scrapes the burrs off of a conduit edge. There are a few types of tools that will quickly ream the edge of the conduit. A cone-shaped reamer works by scraping a bevel on the inside edge of the conduit as the tool is rotated around the conduit. Another type of reamer is attached to the shank of a screwdriver and contains a cutting edge for a half, 3/4, and 1-inch conduit. The tool is inserted into the conduit and rotated to remove the burrs of the inside of the and outside edges at the same time. Finally, a metal file can be used to accomplish the same task as the previous specialty tools while having many other uses as well. Bending. A smaller conduit can be bent with appropriately named conduit bender. There are markings on these tools that, with practice, make conduit bending a reliable and consistent process. Conduit that is too rigid or large for a bender can be bent with a hickey, a tool that bends the conduit with multiple movements per bend. See Figure 3-20. If the conduit is too large for either of these tools, a power-assisted hydraulic bender is needed. Non-metallic conduit must be heated before it could be bent. A blanket heater or a box heater will bring the non-metallic conduit to the proper temperature for bending. Do not use a blowtorch, automobile exhaust, or any other method that may be suggested as an electrician's tip. These shortcuts are not only dangerous, they are not allowed by the National Electrical Code. A hammer is used for driving nails and staples, attaching hangers and electrical boxes, striking chisels, and driving ground rods. Many electricians prefer the electrician's hammer to a standard claw hammer because the electrician's hammer has an extra long neck for driving nails through the bottom of an electrical box. The claw, which is straight rather than curved, is used to remove nails and loosen structural materials such as plaster during electrical remodeling. See Figure 3-21. A lineman's hammer is heavy enough to drive a ground rod. The general rules regarding the proper use of striking tools follow. Always choose the right size and weight hammer for the intended use. Never strike tools together unless they are designed for that purpose. Striking tools should strike a surface squarely, never at an angle. Always wear safety glasses when using striking tools. Drilling. Whether a corded or cordless electric drill, the common function is to make a round hole. In order to accomplish this, the tool must be in good working condition. The bit must be sharp, the proper type, and the correct size for the hole and material you are drilling. Figure 3-22 illustrates a typical cordless drill kit, a variety of drill bits, accessories, and hole saws. A hammer drill is a drill that delivers an impact to the drill bit while it is turning. This is useful when drilling in cinder block or concrete. A rotary hammer drill is a tool that delivers a significant impact to the drill bit when it is turning. The impact is so strong that special bits must be used. Rotary hammer drills are used when drilling large diameter holes in hard materials. See figure 3-23. Soldering. The development of various types of wire connectors and the development of various types of wire connectors has all but eliminated the once common technique of joining wires by soldering. This still soldering may occasionally be necessary. Upon such rare occasions, a soldering gun, a spool of solder, and soldering paste, also known as flux, will handle the task, such as seen in figure 3-24. Soldering tools require almost no maintenance except for occasional cleaning or cleaning of the soldering tip, with instructions provided by the manufacturer are adequate for the care and use of these tools. Miscellaneous. In addition to those previously described, the following basic hand tools should be included in your toolbox. See figure 3-25. Screwdrivers, assorted sizes and types, including both Phillips and standard tips. Allen wrench set. This is necessary to tighten main lugs on certain load cutters and panels. Plaster knife, a wide and flexible type, is used to repair damaged plaster when remodeling old work. Set of sockets and ratchet wrench. These tools can be used when attaching a conductor to a grounding rod. Trouble light. You may have to work in unlit attics and crawl spaces. Tool pouch. Carry the tools you use most often in a pouch so you do not waste time going back to your toolbox. Adjustable wrench. This wrench is able to tighten and loosen most nuts and bolts. Ladders. A good fiberglass or wood step ladder and extension ladder are needed at most jobs. The gimlet or scrawl or scratch awl. Gimlet or scratch awl. Installation of screws is much easier and faster when a starter hole can be created with one of these tools. A crosscut saw. This saw is needed for notching or cutting studs. Keyhole saw. Use this tool to quickly cut drywall without requiring a starter hole. Wood chisel. This tool will trim away small amounts of wood in framing members to make room for conduit, cable, or boxes. Aviation or tin snips. These sheet metal cutting tools are useful for some cabling covers to create the leverage to cut metal. Aviation snips use compound action, and the tin snips have long handles. Professional tip. Mark your screwdrivers. Mark the top of your screwdriver handles with a plus or minus symbol so you know the tip style before pulling the screwdriver out of your pouch. Some screwdrivers may already have this mark. Care and repair for tools. Knives, drills, bits, chisels, saws, and other tools meant for cutting should be kept sharp. A dull tool does poor work and is also more likely to cause injury to a worker or damage nearby materials. Gripping tools or turning tools such as pliers and screwdrivers should be inspected frequently. Pliers with rounded teeth will slip and may cause damage or scraped knuckles. Inspect screwdriver blades for rounding and other signs of damage and wear. If reconditioning the tool is impossible, or costs more than the new one, replace the tool. Handles of striking tools should be inspected frequently for looseness and weakness. Wooden handles can crack and splinter from misuse or misdirected blows. Loose wooden handles can be repaired with new wedges. Broken handles should be replaced. Proper use and care of tools should be a part of every electrician's training. For additional training or information, go to the website www.hti.org for additional information concerning the proper use of hand tools. Visit the Hand Tool Institute website. Some review questions. Number 1, list the 3 types of rules needed for measuring distance. One is the steel tape. The other one is the folding extension rule. The other one is the 100-foot tape rule, which could come in other sizes, including over 100 feet or slightly under 100 feet. Another question is number 2, true or false, a cable ripper is used on a single conductor wire. That would be false, is used for a multi-wire conductor jacket to rip the outer jacket of a multi-wired cable. Number 3, how is an electrician's hammer different from a standard claw hammer? It has a longer neck. It is heavy enough to drive some ground rods, and it is made, its handle is made either of wood or fiberglass. Number 4, which of the following statements is true when using cutting tools such as cable cutters and side cutters? A, never use more than reasonable hand pressure. B, use a handle extender if the material does not cut easily. And C, it is acceptable to use a hammer to make the cutters cut the material. A is the true one, never use more than reasonable hand pressure. The other ones are obviously false. 5, fill in the blank. Blank. What are blank are used for holding, shaping, and cutting wire? That would be electrical pliers or lineman's pliers. Question 6, carry your most frequently used tools in blank to prevent multiple trips to your toolbox. That would be a pouch. 7, why are insulated tools important? And that would be to prevent electrical shock from live equipment if you must work in them. Remember, the best way to prevent any kind of injury or shock is not to work on live equipment as much possible, as if at all possible. If you must work on live equipment, make sure you use not only your insulated tools but also your insulated gloves and PPE such as safety glasses and even safety gear for arc flash prevention. And you can learn about arc flash in later chapters or by researching about this. Know the code. A copy of the NEC 2011 is required to answer these questions. That would be NEC 2017 for this recording, which was done in early 2018. Question number 1, is the Nfpa responsible for enforcing the requirements of the NEC? If not, who is it? The Nfpa is not responsible for the enforcement. Local municipalities, governments, and inspection agencies from your local city, state, or federal location or authority is the body that is responsible for the enforcing of the NEC regulations, the Nfpa NEC regulations. The Nfpa NEC is only a guideline, a set of rules, a set of regulations that municipalities follow, that states and the federal government follow. It is not a agency which enforces the law. Only agencies from the government, whether it's local, state, or federal, can enforce laws. Are all requirements of the NEC mandatory? If they are, please explain. Not all requirements of the NEC are mandatory in all areas. However, most areas in the United States, most governments, municipalities, cities, states in the US do follow most, or all of the NEC requirements. Thus, the NEC becomes a set of regulations that must be followed, or that are in fact mandatory. Number 3, what units of measurements, the measurement system, are used in the NEC? And that would be the imperial or English type of measurement for physical measurements in foot, inches, etc., yards. And the electrical units are from the Système International, or the SI system, which is an internationally recognized system where you use metric units such as the ohm, the volt, the ampere, the mega, the kilo, the milli, and many other notations, such as the engineering type notation, like the amount of electrons denoted or described by a column, which is what? Can you say it? 6.24 times what? Times 10 to the 18th power. That would be engineering notation denoting that 6.24 billion electrons are basically the measurement of a coulomb, which is the measurement for current or amperage. And that is the end of this chapter, chapter 3, part of section 1, fundamentals, tools for the electrician. Thank you for listening and reviewing and studying this chapter. Please continue with your studies and complete the entire electrician program to become an apprentice electrician, and you'll be on your way to be a professional electrician. This has been a recording in February 2018 from a location here in Virginia Beach, Virginia, in the United States. This is Hector Vladimir, reading from material by H.N. Holzman, which is the Modern Residential Wiring Textbook, 9th edition. Again, thank you for listening, and look for the next chapter.